Hello. Thank you for the opportunity to present my research. I am grateful for the guidance by Dr. Liang and the supporting committee members. My name is Evan Gertis. In this presentation, we will discuss the design and implementation of the automatic word match generator. Practice cannot fail. For the things we have to learn before we can do them, we learn by doing them. Men become builders by building, and lyre players by playing the lyre. Aristotle. An automatic word match generator is a software tool that can be used to generate word matching interactives automatically. The purpose of a word matching interactive is to provide students with a mechanism to learn new vocabulary and improve their reading comprehension skills. This thesis will present the design and implementation of an automatic word match generator, as well as the research and algorithms used in the program. In this presentation, we will review the problem and motivation behind what we did, the literature supporting our research, and the methodology that we followed. Finally, we will show the results of our efforts. Students tend to face difficulties when they are required to learn new terminology. For example, understanding how to differentiate between the terms hardware and software can be challenging for beginner computer science students. Word matching games have been used by instructors to teach vocabulary to students. Previous researchers, Nikma and Hussein in 2010, utilized a technique called Make-A-Match, which has been shown to be successful for teaching vocabulary and reading comprehension skills. Al-Masari and Najjar applied this concept, except they used pictures and words. FastForward Products developed a set of software-based word matching games that were shown to improve reading comprehension skills, as shown by the Brigance Comprehensive Inventory of Skills test. We also saw that Google Trends recorded an increased usage of Udemy during the pandemic around March of 2020. This indicates that there was an uptick in the usage of online learning. The trend could indicate that online learning is now accepted. And online learning platforms like Revel use interactives which have been shown to help students improve their average quiz letter grades and final grades. We'll go through the literature used in this thesis. Figure 1 shows an example of a make-a-match exercise. Forma Quran originally created the make-a-match in 1994. Nikma and Hussein split students into two groups, A and B. Group A got a question while Group B received answer cards. They used this technique to test students' ability to match keywords with their descriptions. Al-Masari and Najjar used a variation of this technique, except theirs leveraged pictures and words. In both cases, the average post-test score in the experimental group was higher than the average score in the control group. Nikma and Hussein's research revealed post-test scores of 80.40 in their experimental group and 77.20 in their control group. The measured p-value of the post-test was less than the significance value of 0.05. The results of a two-tailed t-test with a degree of freedom of 29 was 19.282, which was greater than the t-value of 2.045. FastForward Products took a previously successful concept, computer software, that focuses on developing learning and cognitive skills, and improved upon it. They provided computer-based products that combined optimal learning environments with a focus on early reading and cognitive skills. Figure 2 demonstrates that students gained 3 and 1.5 years in reading grade level. Specifically, if we look at the red curve, we can see that as students participated over time, the consistency of their ability to match words with their descriptions increased and eventually reached a steady state level. Their average letter word identification improved by 14 months. Their average gain on the Woodcock-Johnson 3 test of achievement was 2 years. This figure shows a spike in Udemy usage during the pandemic. It is possible that the consequences of the pandemic were unstoppable and uncontrollable for higher education industries, much like the rest of the world. Most higher education systems are now operating through e-learning platforms. It is possible that the stabilization of this curve implies that the world has adopted the usage of online learning platforms like Udemy, Unacademy, Swayam, and edX. Our research will help students who are either studying or working remotely. Revel is a program that is used both at home and in class. It is an online learning platform. It provides students with a process for practicing what they've learned. Revel Interactives provide integrated live examples that help students improve retention of key programming concepts through the application of running and modifying live code. Figure 4 shows a strong positive correlation exists between Revel grades and average quiz grades, where R, the correlation coefficient, is a value of 0.50. R measures the strength and direction of a linear relationship between two variables on a scattered plot. In this example, we see it is the average Revel grade and the average quiz grade. The p-value measured with this experiment was less than 0.01. Therefore, the null hypothesis was rejected and the alternative hypothesis is accepted. Figure 5 shows that the higher the Revel grade, the higher the average exam grade, specifically 17% increase. And the lab grade was a 32% increase, and the final course grade was a 12% increase. Figure 6 shows that there's a strong positive correlation between Revel grades and final grades, where the correlation coefficient is a value of 0.67, indicating that it is a positive correlation. There's a positive relationship between the final course grade and the average Revel grade. Again, the p-value measured in this statistical analysis was less than 0.01. Figure 7 shows that the higher the average Revel grade, the higher the average quiz letter grade. As we can see here, at least a 22% increase. Figure 8 shows that the average exam grade increased from 59% to 70% from spring of 2015 to fall of 2015 for students who used Revel. Figure 9 shows the average exam grades for spring of 2015 and fall of 2015. In this study, the t-test measures whether the means of the two groups are statistically different. The results of the t-test show that students in fall of 2015 had a mean score of 70%, which implies that they scored higher since the score for spring of 2015 was 59%. These tests use a sample size of 118, and the t-value associated with that was negative 2.14. And p was less than 0.05, indicating that this was an increase and is statistically significant. Now we will review the requirement specification. Instructors shall be able to automatically create interactive word matching games. Students shall be able to access the games online. From a developer perspective, the following specifications were required. Enable the storage and retrieval of word matching interactives, capture the input data necessary to create word matching interactives, provide a web interface for displaying word matching interactives, develop a drag and drop algorithm that facilitates an interactive learning experience using the derived data from the output. Figure 10 shows a before and after picture of the automatic word match generator. The implementation of the custom three-tiered application was not trivial. As we can see in the top left, the before picture is the static HTML, JavaScript, CSS word matching interactive that we started with. In the bottom, we see the full-scale custom multi-tiered application that was used to create the automatic word match generator. An instructor accesses the tool by going to the graphical user interface. They enter the key terms and descriptions. After they've completed that action, they click Generate HTML, which will present the HTML in the Generate HTML text box. There they can see specifically exactly what lines of code were used to create the word matching interactive. Then they click Post. After they click Post, a request is sent to the server. This post request follows an HTTP protocol. It has the content of the word matching interactive. That is processed by a handler. The handler routes the request to a controller. The controller calls a service method from the word match service, as we can see here in the service box. That will process the request, take the content, and save it on the server. After that action is complete, a response is returned back to the server of 201 created. That will provide the instructor with a view button. When they click this view button, A request will be made to the server via GET request, which is following the HTTP protocol. That GET request will return the view by the exercise ID. This URL can be passed to a student so that they may access the word matching interactive. First, we selected languages for developing the program. Java was selected based on both mine and Dr. Liang's familiarity with Java. Then we identified the input and output. Then we implemented the functionality based on the requirement specification. We will discuss what a word matching interactive is in subsequent slides. Now we'll go through the algorithm design. The crux of this algorithm is the conditional comparison of the source index and the target index. In step 1, we obtain the index of the dragged key term as a source index. In step 2, we obtain the index of the row where the key term was dropped as a target index. In step 3, if the source index is not equal to the target index, we return the key term back to the original position. If it isn't, then we disable the key term object to be undraggable, set a new color for the match row object, and then test if all key terms are matched. If so, we display a congratulations dialog box and increase the success count by 1. Figure 11 shows the user interface that would be presented to an instructor. Figure 12 shows the user interface after it has been pre-populated with key terms and descriptions. Figure 13 shows the instructor's interface after the static HTML has been generated. The window at the bottom of the page shows the code used to create a word matching interactive. Figure 14 shows the instructor user interface after the word matching interactive has been posted to the server. Figure 15 shows the word matching interactive that features the key terms and descriptions from Introduction to Java Programming. So, the basis of our research stemmed from generative programming and code generation. Generative programming is the application of reusing code for a new function or software, and code generation is a mechanism to produce the executable form of a program. Now we'll discuss automatic programming. A generic input can be applied to this process. Then a web page output can be generated. In the case of the automatic word match generator, number 1, input is entered from text fields and stored in arrays. Validation checks if the key terms or their descriptions are empty. In process data, the data is shuffled randomly and the keys are mapped with descriptions. In step 4, we create a web page, and this web page uses HTML, CSS, and JavaScript to produce a word matching interactive. In step 5, we post the web page. Post web page automatically posts the generated web page on a web server so that the page can be viewed on the internet. In conclusion, word matching interactives provide students with a mechanism to improve their vocabulary and reading comprehension skills as shown in the learning curve from FastForward Products in Figure 4. Interactives have been shown to improve student performance on quizzes and tests as shown by the results from Revel, shown in Figures 5 through 9. In addition, the problem that we solved in approaching this is we reduced the amount of time that it takes to create these word matching interactives and completely automated the process of creating word matching games, providing a very valuable contribution for instructors. We'll now work through a live example. We'll go to the word matching generator UI. Here we'll enter a title for our test. We'll click Generate HTML. This presents us with the HTML for Word Matching Interactive. Now we'll click Save and View. Here we have our key terms and descriptions. So here are our key terms in the key term pool and our descriptions. We'll go ahead and activate the speech synthesis, which will help students who have difficulty reading a screen. We'll try to drag the incorrect term here. Gets returned back to the key term pool. Go ahead and drag it to the
Cabello,
correct term.
horse,
Now drag this to the correct term.
burro, donkey,
There we go. Now click Show Answer. We can see that caballo is matched with horse, burro is matched with donkey, and click OK. Are there any questions? A quick search of similar products shows examples of sites that are overly complicated and difficult to use. For example, the Teacher's Corner. This Teacher's Corner website has tons of ads and tons of distractions which are difficult for students to stay away from. This site is ineffective because it is covered in ads. It's frustrating to use. Just trying to type in a key term and definition opens an ad tab, which is not made for instructors. It's a gimmick. As we can see here, the main page, typing in our information, then trying to save it. This menu pops open as soon as we try to enter text. It's very ineffective. Our word matching interactives are being used in Revel, which is a reputable online platform. It's been proven to be successful. It's helping to save instructors time. We can see its usage right here. In addition, we can also see how the word matching interactives are being used to teach students right now. Here's a live recording of students actually using the product.
No. I just say equal sign. The equal signs goes to the bottom.
equals. Assignment operator assigns a value to a variable.
The Woodcock-Johnson tests of achievement includes 22 tests for measuring skills, reading, mathematics, writing, as well as important oral language abilities and academic knowledge. There's two parallel forms, Form A and Form B, which contain 22 tests. The Woodcock-Johnson 3 tests of achievement are used to frequently test reading, mathematics, and writing tests. The researchers in Al-Masari and Najjar used a two-way ANOVA test, which is a statistical test used to determine the effect of two nominal predictor values on a continuous outcome variable. If you go to the tables for those two papers, you can see that there's a statistical significance between the control group and the experimental group. We can see that every time the experimental group outperforms the control group. We can also look back at the learning curve from the FastForward Products paper to see how this is effective. FastForward Products uses games like Canine Crew, Squirrels Out, Mama Bear, Bear Bag Out, which gets students to actually match key terms with which gets students to match terms with pictures, and it's been proven to be effective in helping them improve their reading comprehension skills. The difference between our work and their work is that this is solving a problem for instructors. Instructors can use this tool to create word matching interactives on the fly. So it aligns with automatic programming. The generic model that we're using can be applied to any web page input. So the next logical example here would be to use a code animation tool. We could take a code animation and then we can automate the generation of that site using the automatic word match generator.